There are currently no visible crystals. This means that I am unable to comment on the shape or the size of the crystals at this time. Crystal formation has possibly started on the microscopic scale and not yet reached the point where it is visible to the human eye. This is because it takes a long time for crystals to bond in an orderly way to form the near-perfect geometric shape for which we are aiming. In order to prepare the solution that yields the formation of alum crystals, we started by dissolving scrap aluminum foil in potassium hydroxide solution. This reaction yielded hydrogen gas that bubbled out as the reaction proceeded, and aqueous aluminum ions in a basic solution. In order to speed up the reaction, the beaker holding the aluminum-potassium hydroxide solution was placed on a hot plate and mixed using a magnetic stir bar. Impurities in the tinted foil precipitated out of the solution in the form of a dark magnetic solid. Much of the solid particulates stuck to the magnetic stir bar as the reaction proceeded towards completion. In order to separate all the solid precipitate from the aluminum and potassium solution, the solution was filtered through a filter paper and a Buchner funnel attached to a vacuum pump. Sulfuric acid was then slowly added to the aluminum-potassium hydroxide solution, and initially aluminum hydroxide precipitated outward. The solution was then heated and mixed using a hot plate and a new and clean stir bar. The aluminum hydroxide then dissolved back into solution as the solubility increased with the increased temperature, and the sulfuric acid neutralized the basic aluminum hydroxide solution. After waiting for 30 minutes and adding more sulfuric acid, the solution was immediately placed in an ice bath, rapidly decreasing the solubility of the mixture, causing an alum mixture to precipitate out of the solution. We then filtered the water out of the alum precipitate by using the Buchner funnel attached to a vacuum pump. We mixed the materials until the funnel stopped dripping and then stopped the pump. 50-50 ethanol water solution was subsequently added to help separate the liquid molecules from the alum, since oil and water do not attract. The solution was again mixed until liquid stopped coming out of the funnel. This was repeated 3 times to ensure as much liquid as possible was removed. In order to grow alum crystals, the alum solid mixture was added to water and placed into vials covered with Kim wipes. According to sciencenotes.org, in order to grow NaCl or table salt crystals, I would need to stir salt into boiling water until no more table salt would dissolve. In order to create a large salt crystal, I would have to pour the supersaturated solution into a clear container and place it in a cool shaded area where it could grow undisturbed over time. According to sciencenotes.org, if one wants to grow crystals quickly, one could soak a piece of cardboard in the solution until it is soggy and place it in sunlight. Small crystals would grow in a matter of hours. In order to grow a mass of crystals, one could put the solution in a clear open container and let the water evaporate. These crystals would grow along the sides of the container. If one wants to grow colored salt crystals, they simply would have to add food coloring to the salt solution prior to growing the crystals.